Hi, in this video, we're going to learn about the linear programming model. To do that, we're going to examine one problem. It is about the Woos and their bakery. So let's check it out. This is the problem that we're working with. It's quite long, so I recommend that you pause the video for just a moment. And I'm going to highlight during that pause, for me, what's kind of important to this question. So we see that the Woos are dealing with some different things in order to make their cookies every day. They've got so much cookie dough, 110 pounds a day, different dozens of cookies require different amounts of cookie dough. They've got so much icing for their iced cookies, and they only got so many times in the day. The Woos are busy people. They don't want to be baking cookies 24 hours a day, so they're planning to work 15 hours of baking together over the course of their day. They only have so much space in their ovens. 140 dozen cookies can be baked in a day, and so much time. Different types of cookies take different amount of times to cook. So these are their constraints. We need to kind of like put these into some equations so we can get an idea of like how they're limited by their icing, their oven, and their time to cook. So I've already done the amount of cookie dough. They have 110 pounds of cookie dough. Each dozen plain cookies takes 1 pound of cookie dough. So it's kind of like a 1p. So I'm going to have p represent a dozen plain cookies, and I represent a dozen iced cookies. And each dozen iced cookies take zero point 0.7 pounds of cookie dough, because they got the icing on top just to kind of like even them out with the plain cookies. So now we need to make an equation for icing and space in the oven. Space in the oven is easy. It's just how many dozen plain, how many dozen iced. That has to stay under 140 dozen. If we take a look at how much time they got to prepare for cookies, we know that they're going to spend 15 hours working on their cookies. And then each dozen plain cookies takes zero point 0.1 hours. So every dozen is going to take 0.1. But then the iced cookies take a little bit longer. They take 0.15 for every dozen iced cookies because they got to bake the cookies and then they've got to spend that extra 5/100ths of an hour icing those cookies. Finally, we need to make one more equation for icing. So the iced cookies are the only ones that get iced. Our plain cookies don't get any icing on them. So this last equation is just going to have iced on there. So we can get rid of this P. And we've got 32 pounds of icing. So whatever we do with the iced cookies, we got to stay under 32 pounds. And if I look back here, each dozen iced cookies takes zero point 0.4 pounds. So on this dozens of iced cookies, we want to multiply that by zero point 0.4 because we're going to use 0.4 of a pound of icing for every dozen iced cookies that we make. So those are all the constraints, like mathematically, that the Woos are dealing with. But the Woos are a business, and so they want to be trying to make some money. So let's learn about that. So the way that the Woos sell their cookies is plain cookies sell for $6 a dozen, and they cost $4.50 to make. That's for running the ovens and buying the cookie dough, all that jazz. The iced cookies sell for $7 a dozen and cost $5 to make. So they need a little bit extra money because they got to pay for that icing on there. So we need some sort of additional equation that's trying to represent how much money the Woos are making with these cookies. If we think about their income that they're getting $6 for every plain cookies that they sell, plus they're getting $7 for every dozen iced cookies that they make. But there are costs that go along with these things. So the plain cookies, they lose $4.50 of that $6 in order to like pay for the costs and everything. And then for the iced cookies, they make $7 of income, but they have to pay $5 to get the supplies to like make all those cookies. So we've got 5i. So that's their income and their costs. So their overall profit from each cookies is they get $1.50 from their plain cookies. So they get $1.50 profit on their plain cookies, and they get $2 profit for every dozen iced cookies. Now, unlike the ones on this previous slide here, where I was able to like make the other side of the equation, there really isn't another side of the equation for this thing. It's really just are straight like profit. There's no limit on how much profit the woos are going to make. They're going to try to make as much money as possible. So I don't get two sides of the equation for this thing. We just get one side because there's this odd sort of like profit thing that's not being constrained, unlike all these things over here that are being constrained. They only got so much time, they only got so much cookie dough, they only got so much space in the oven. So the first kind of idea of like how to kind of get an idea of how many plain cookies and how many iced cookies the Woo should be making, is just kind of like guess some numbers so we can get an idea of like what's going on with this problem. That's what I did here. So this is different guesses for how many plain cookies you could make, different guesses for how many iced cookies you could make, and then the profit that would go along with them. Now, this good, no good, we'll get to that in a little bit. But we can kind of see like there's a lot of different values that we could be getting. We could just get $55 a day, or we could get like $900 a day. Unfortunately, some of these we're not able to actually really do because the Woos don't have enough icing to make 300 dozen iced cookies, and they only got so much time in the day to be able to do that. So these particular values aren't that great, are not able to be done, but they got great money. And then these ones are good, but they're not. They can do this, but is that the best? How do we know what the best amount is? And we can keep guessing and guessing and guessing, but we're never going to actually get like a for sure. This is the thing. So what we're going to do is we're going to take those inequalities that we had before, these ones here, and we're going to put them on a graph so that we can like see how these good and not goods are kind of matching up and why. So on a graph paper, you can just kind of quickly make this graph. I'm going to call down here my plain cookie axis, and then this axis up here be my iced cookie axis. So this point right here would mean that I'm making 110 dozen plain cookies, but I'm not making any iced cookies. Or if I went all in on my cookie dough on iced cookies, I could make 157.14. Really, I can make 157 dozen iced cookies based on just cookie dough. If I put all my cookie dough into iced cookies or put all my cookie dough into plain cookies. So that could be one graph. And then if we're just thinking about icing, like based on this icing, we only have one value, I. So we could divide both sides by 0.4. 32 divided by 0.4 gets us 80. So at best, the Woos can only make 80 dozen iced cookies, no more. So that's kind of why some of these options on this table just don't work. Down here, the best iced cookies that we can make is 80. So we can't do any of these, and we can't do this one up top because we just don't have enough icing. This one still seems good. We could make 70 dozen iced cookies, but there must be some other constraint that's keeping us from being able to make 70 plain and 70 dozen iced cookies. So we got icing, we've got all those graphed. Our next one, if we're kind of like graphing these all on the same axis, is oven space. So we can make 140 dozen iced cookies or 140 dozen iced cookies. That 70 and 70 should be right here. So that should still work in terms of our oven space. Would it work in terms of our cookie dough? Is that not going to work? That's not going to work. So look, 70 and then 70 is going to fall outside the amount of cookie dough that we're able to have in a day. We just don't have enough cookie dough to do 70 and 70 for plain and iced cookies. Our last thing is our prep time. So if the Woos did nothing but made iced cookies, they could make 100 dozen iced cookies. Or if they did nothing but make plain cookies, they could make 150 dozen plain cookies. Now, we made all those graphs so that we could then put them all on a single graph. And this is the graph that you really want to have in your notes. You've got all of those inequalities up here, and you've got all of the kind of constraints on the Woos. If you are not making this graph, now's the time to pause the video and make this graph. Looking at this graph, we can kind of see like, hey, you want to try to use up all your stuff, Woos. So trying to use up all your icing is a great idea. But anything the Woos are able to do has got to be in this area right here. This area is called the feasible region. This is the area of what the Woos are actually able to do. Now note that I didn't graph profit. And also note, look at this oven space of what the woos are able to do, the woos are never going to be able to fill their ovens because they're never going to be able to get themselves up against that oven line because they're either going to be constricted by the amount of dough they have. Maybe they're going to be constricted here by the amount of time that they have to make cookies, or maybe they're going to be restricted here by the amount of icing that they've got uh, to put on the cookies. So, whatever answer we give the woos, it's got to be somewhere in here. So, next, what I did is, like I said, profit is not graphed. If we did graph profit, the idea is we would take coordinate points on here, and each coordinate point would have a money value from that table. So, that looks like this. So, this point right here is that point of doing 20 dozen 20 dozen plain cookies and 10 dozen iced cookies. That would get us $55 for the day. This point up here at 0.20 from that table before is saying that, hey, if we did 120 dozen iced cookies, we get $240 profit for that day. But we can see that's outside of this feasible region. So we can't do any of these points out here. We can do any of these points here. But also then you can kind of see there's a whole ton of points, and I'm not going to spend forever checking every last combination. We need some better way of thinking about what's going on. Something I'm noticing is as I move away from the origin, as I kind of head in this direction, the values get bigger and bigger. So as I move across, I get bigger and bigger values. So I'm guessing it's going to be somewhere along here is going to be where our maximum amount of profit is going to be, because I want to try to push my way up towards this 375 because that's the best profit that we've seen. But still, that's still a lot of options. Fortunately, we have this very important theorem that you're going to write down. This, in a system of linear quantities, the maximum and minimum values of its output function is at the corners of the feasible region. We've got a system of linear inequalities, and we're checking that graph. The maximum and minimum output, that's our profit. Our profit is our output function from all those little coordinate points. The output function is never graphed, but it is the thing that we're trying to maximize or minimize. So we know then that the maximum value has got to be at one of these points. That's why those letters were here. A, B, C, D, or E. And one of them is going to be the minimum value. And I bet you know which one that's going to be. That's going to be E. If the woos do nothing, they're not going to make any cookies and they're not going to make any profit. So this is going to be our worst option possible. Now, using just like substitution, elimination stuff, we can figure out where all these coordinate points are. So we know A is at 0, 80 because we know this line just right here is 80. This point right here is going to be 30, 80. So we would plug 80 into our time equation and see that we get 30. This one we were talking about before with dough, that's just getting 0 iced cookies. That would make 110 dozen plain. And then this point right here, we'd actually have to do substitution, shoving one equation into the other, or we could do it with elimination. But we do get this coordinate point, 75, 50. So now we know one of these 5 is going to be our maximum value. So it's a lot easier to check these 5 versus the infinite number of points that are in this feasible region. So we just got to check them one by one. So if we do 0, I'm going to borrow this. 0, as I was saying before, if we do 0 iced cookies, and then 0 plain cookies, our profit is going to be 0. So I know that that is the minimum value that the woos are going to be dealing with. So that's definitely not what they want to do. If I check this one, I've got 80 iced cookies. Remember that I is that second value. 80 iced cookies and no plain cookies. So that's just going to be 20 times 80. That's going to be $160. And I've seen values bigger than 160. So I'm hoping the woos can do better than 160. If I check this next one, so this one's not going to do any iced cookies, and then we're going to do $110 for our plain cookies. 1.5 times 110 is $165. So that is a little bit better. It's not great. But let's see what we can do better. So if we try this one, 75.50, that 50, our second number, is our iced cookies. And then 75 is our plain cookies. So that is going to be 100 plus 112.5, which equals 212.5. Ooh, that's pretty good. $212.50 a day. That's not bad for the woos. Now we just got this last one to check and see if that's going to be 212.5. So let's see. That's going to be 80 iced cookies and then 30 plain cookies. So that's going to be $160 plus 30 times 1.5. That's going to be $45. So that's going to give the woos a total profit of 205, which is still a little bit less. So this has to be the maximum profit for the woos. So our maximum profit has to be right here, which makes sense because we're trying to do a good mixture of plain and iced cookies. We're using up all our dough. We're not wasting any of the woo's time. We have some icing that's kind of left over, but if we try to head more towards that icing value, we're decreasing our profits by just a little bit. So this is going to be our best place for the woos to make a profit. And this is the worst place for them to do. And that's it for our video. Reminder with these linear programming problems that you're going to have a system of inequalities and something that you're trying to maximize. That thing you're trying to maximize says profit doesn't get graphed other than giving a value to each coordinate point on your graph. Your maximum value and your minimum value is always going to be at the corners of these feasible regions. So you just got to check all the corners and see which one gives you the best value. Thanks for watching. Hope you enjoyed Woo's Cookies. Bye-bye.